All right. So we are live right now. I hope I'm audible to all of you. Please let me know in the live chat. Welcome everyone. Welcome back. All right. So, so in today's session, we are again going to discuss about the differential equations, right? So as of the last lecture, if you haven't watched the last lecture, I would request all of you to please go back and watch the previous lecture before we start to discuss about today's topic. Okay. So in today's session, we are going to discuss about orthogonal trajectory, and along with that, we are also going to discuss about exact differential. हाय रश्मि प्रिया, कॉम्प्लेक्स नंबर पढ़ा दीजिए. जरूर, कॉम्प्लेक्स नंबर मैं डेफिनेटली पढ़ाने वाला हूँ, राइट. बट पहले सबसे पहले जो हाई वेटेज और जो सबसे इम्पोर्टेंट चैप्टर्स है, जो आपका जेई मेंस और एडवांस के लिए सबसे ज्यादा इम्पोर्टेंट है, वो सब चैप्टर्स मैं पहले कवर करने वाला हूँ. ओके. तो सबसे पहले जैसे मैं कैलकुलस कवर कर रहा हूँ, इसके बाद मैं वेक्टर्स एंड 3D ज्योमेट्री कवर करूंगा. ओके. एंड जैसे वेक्टर्स एंड 3D ज्योमेट्री खत्म हो जाएगा, देन वी विल गो टू कोऑर्डिनेट ज्योमेट्री, राइट. एंड दिस ऑल बेस्ड अपॉन द प्रीवियस ईयर क्वेश्चन एनालिसिस. ठीक है. तो अगर तुम प्रीवियस ईयर क्वेश्चन को थोड़ा एनालाइज करते हो, देखोगे कि जो टॉपिक्स सबसे ज्यादा इंपॉर्टेंट है, जिसपे स्कोर ज्यादा कर सकते हो, उसी टॉपिक्स को मैं पहले पढ़ा रहा हूँ. जैसे वो टॉपिक्स खत्म होने वाला है, फिर मैं अलजेब्रा वाला पार्ट भी कवर करूंगा. ओके. सो डेफिनेटली कॉम्प्लेक्स नंबर होने वाला है इस चैनल पे. ठीक है. सो थोड़ा वेट करो. बट सबसे पहले अभी जेई मेंस का अटेम्प्ट, जनवरी अटेम्प्ट सामने है, तो पहले वो खत्म कर लेते हैं. ठीक है. ऑलराइट. सो आई होप दिस इज क्लियर. सो विद दिस लेट्स डिस्कस अबाउट द होमवर्क सॉल्यूशन, राइट. सो मैं लास्ट क्लास में आप सभी को मैं कुछ क्वेश्चंस करने के लिए बोला था, राइट. आई होप आपको लास्ट क्लास का पढ़ाई हुआ चीज समझ में आया होगा. एंड विद दिस, ये जो क्वेश्चंस था वो मैंने करने के लिए आपको बोला था, राइट. एनी वन ऑफ यू हैव सॉल्व दिस प्रॉब्लम्स? किसी ने क्वेश्चन को करने का ट्राई किया होगा? ओके. सो अगर आप क्वेश्चन थर्ड को देखोगे, जो मैं बोला था पहला होमवर्क पे, अगर आप क्वेश्चन नंबर थर्ड को देखते हो, राइट, तो इसमें क्या बोला है कि आपके पास एक डिफरेंशियल इक्वेशन है जो काफी नॉन लीनियर फॉर्म में दिख रहा है, राइट. नाउ इसको इजीली सॉल्व करने के लिए क्या करोगे आप यहाँ पे एक सिंपली एक ट्रांसफॉर्मेशन करोगे, राइट. दैट इज, सबसे पहले आप एक काम करो कि आप जहाँ पे देख रहे हो ना, यहाँ ये वाला टर्म एक्स प्लस वाई और एक्स प्लस वाई वाला टर्म जो रिपीट हो रहा है यहाँ पे, आप सबसे पहले इसको एक्सप्रेस कर लो सिंप्लीफाइड फॉर्म में, राइट. सो फर्स्ट ऑफ ऑल ट्राई टू एक्सप्रेस दी नॉन लीनियर डिफरेंशियल इक्वेशन इन सिंप्लीफाइड फॉर्म, और जो वाला पार्ट अलजेब्रा से कट रहा है उसको हटा दो आप. ठीक है. So if I discuss about this solution, so if I discuss about question number 3, so let me discuss about question number 3. So जो इक्वेशन आपके पास दे रखा है dy अपॉन dx, मैं उसी को रिप्लेस करके क्या से लिख रहा हूँ, मैं लिख रहा हूँ dy अपॉन dx प्लस ऑफ 1, ये जो 1 वाला पार्ट है मैं इसको लेफ्ट हैंड साइड में लेके आ रहा हूँ, एंड देन आई कैन राइट प्लस x इंटू एक्स प्लस वाई इज इक्वल टू एक्स क्यूब इंटू एक्स प्लस वाई होल क्यूब, राइट. ये काफी इंटरेस्टिंग क्वेश्चन है, अच्छे से सीख लो ये वाला. सो नाउ अगर मैं इसको ऐसे लिख सकता हूँ, नाउ फ्रॉम हियर वन इंटरेस्टिंग कैच ओवर हियर इज दैट if you can see कि this particular part, that x plus y term is basically repeating, right. The x plus y term is basically present twice, right. So what if I can take x plus y as some variable, then my solution would be much easier in terms of solving, right. What I'm going to understand over here is that also if I look at this particular term, that is 1 over here, now 1 can be given as the derivative of x, right. 1 can be given as the derivative of x. So therefore I can club this particular term and I can write this as dy dx of x plus y, right. And then I will write this as x into x plus y is equal to x cube into x plus y whole cube. Now if I assume x plus y is equal to t, now if I assume x plus y equal to t, then I can write this differential equation as dt upon dx plus x into t is equal to x cube into t cube, right. Now if you recall that this is another nonlinear form of differential equation which we already studied under the tag of Bernoulli equation. So this is basically reduced to a Bernoulli differential equation right now over here, right. So this is a Bernoulli differential equation. Okay, so Bernoulli differential equation, right? And if you recall, the solution of Bernoulli differential equation was that, so over here the t cube term is making this non-linear differential equation, right? So I'm going to divide by t cube on both this side, and then I'm going to assume, 1 upon t square as some another variable v. Okay, then in this case, if I assume 1 upon t square as another variable v, then in this case 1 upon 2 uh, 1 upon, sorry, this will be like minus 2 times of, this will be minus 2 times of t cube dt upon dx is equals to dv upon dx, right? Okay, so from here, then I can replace this 1 upon t cube dt upon dx term over here with this, and this will be basically dv upon dx by 2 minus x into v is equals to minus x cube, right? I hope this is clear. So I can club these two and I can write it as dv upon dx minus, this will be minus 2 into xv is equal to minus 2 times of x cube. Now finally we have reduced the following differential equation in the form of a simple linear differential equation, right? So from here you can easily know the solution is very simple. The integrating factor is basically e to the power integration of minus 2x dx, which is basically equal to e to the power minus x square, and therefore the general solution, and therefore the general solution so the general solution is now going to look like as v into e to the power minus x square is equal to integration of minus 2 x cube into e to the power minus x square, right? Now again, to solve this equation, again a very simple trick, that I have x cube which I can write as x into x square, right? So if I just replace by this particular term, then I can take minus x square as t, and then this will become t into e to the power t as the final substitution, right? So you can do this integration very simply. So the final result of the general solution in terms of v will look like v into e to the power minus x square is equals to x square plus of 1 into e to the power minus x square plus some constant c. Now if I replace v with 1 upon t square, and t was basically x plus y whole square, so the final solution is basically going to be x plus y whole square is equals to some constant time e to the power minus x square plus x square plus of 1. Okay, I hope this solution is clear to all of you. Okay, so so it should be minus and it should be plus, right? That's why I'm taking it out. Okay, so I'm taking this e to the power minus x square as common, so this will be basically this part, and this part will cancel, and there will be multiplied with e to the power x square. Okay, so I hope this step is clear. So finally the general solution of the final differential equation is going to be, or the solution of the differential equation is going to be looking like this. Okay, I hope this solution is clear to all of you. I assume this solution is clear to all of you, right? If you still have any questions, any queries, you can let me know in the live chat. You can let me know of any questions you have in the live chat so that we can discuss about that. Okay, I hope this solution is clear. All right, any one of you have got this particular answer? Please let me know in the live chat. Did you try to get to this answer or not? Okay, the idea was fairly simple. If you look at the solutions, that they will actually, so if you proceed the solution step by step, it will actually give you the hint. Okay, so looking at the problem, you will obviously get a quite a wonderful hint over here, right? That basically gives you that idea to express this in terms of derivative of x plus y, right? So this was the beautiful catch in this particular problem. So if you just try to go with the flow, you will be able to solve this problem easily, right? Now if you look at the fourth problem, now fourth problem is again very simple problem. So you can again do this problem by expressing it in dy upon dx form. Shashidhar, hi. Alright, so I can write this as dy upon dx is basically equals to, so this is cos of y, so this will basically be equals to tan of y, so this will be tan of y minus x times of, uh, I will have tan of y into cos of y. Alright, so if I replace this over here, so I can write this expression as dy upon dx minus 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 over here it will be, uh, so I can take this particular term, right? I can take this particular term, that is cos a y into tan y into x is equals to tan of y, right? Alright, but if you try to solve this problem in this particular manner, I'm afraid that you won't be able to proceed for any favorable solution. Whereas if I do the reverse step, instead of dividing by sin y, if I divide it by cos y over here, then I can write this differential equation as, so this will be secant y, so I'm dividing by cos square y, okay. So then sin upon cos will become tan, I don't know why it's not working, anyways. Alright, so this will be secant y into tan y minus secant y minus secant y is equal to minus of x, right? So from here, if you assume this secant of y as some another variable t, then secant y tan y dy by dx will become that particular derivative, right? So if I assume secant y as some variable v, so from here you will get to the required form, that is dv upon dx is equals to secant y into tan y dy upon dx, right? So this differential equation would be further reduced to dv upon dx minus v is equals to x, sorry, is equals to minus of x, right? So this will be the linear differential equation. Now from here, I hope you know how to solve this differential equation, right? It's further easy from here, right? Alright, so you can solve this differential equation to get to the final general solution. Alright, so if you look at the answer, the final general solution would be like, okay, so if you look at the general solution of the answer, it is basically secant y is equals to 1 plus x is equals to 1 plus x come constant times of e to the power x, okay. So this is going to be the final general solution, okay. This is going to be the final general solution. I hope this is clear to all of you. I hope this solution is clear to all of you. Alright, so these are the discussion of the homework problems that I gave you in the last class, okay. So if you still have any confusion or any doubts, you can go back to the previous lecture that I took last day, so and you can watch that particular session to understand about this particular differential equation solution, okay. So you can go back and watch that particular session to get an understanding or an idea over it, okay. So today, let's start with our today's discussion, that is going to be on orthogonal trajectory. Okay, so I'm going to start about discussing about the orthogonal trajectory. So let's try to understand what do I actually mean by orthogonal trajectory, right? Now, if you recall the definition of the word trajectory, so what do we mean by trajectory is that trajectory generally refers to a path taken by an object or the curve, right? So trajectory refers to a curve. So trajectory refers to a curve. Now, what is orthogonal trajectory? Orthogonal means something which is perpendicular. So, if I find a set of family of curve which is perpendicular to the following curve, then that is known as orthogonal trajectory for any of the particular family of curves, right? So, for any curve which cuts every member of the given family at a 90-degree angle or right angle, then such trajectory is known as orthogonal trajectory of the family. So, for example, if I have multiple set of curves like this or family of curves, then another family of curve which cuts every family of curves at 90-degree angle, then such particular trajectory or such particular set of curves is basically known as orthogonal trajectory for the given family, right? So, if I take a very simple example, I can take a simple example of circle, right? So, if I take a simple example of circle, so let me take a simple example of circle, okay? So, if I have a circle with a center C over O over here, is the x-axis and this is the y-axis, right? So, this is my equation of circle, and I will prove that how the circle have the orthogonal trajectory as some straight lines, right? So, if I look at this circle over here, so if I take a multiple family of circles also, now if I draw any straight line like this passing to the origin or the center, then every set of lines is going to cut the circle at 90-degree angle, right? Now, before we understand our 90-degree angle, it is very important to understand that how do we actually get the angle between the curves. So, in order to find the angle between the curves, what we do is that, so for example, if I need to find the angle between the curves, which we have already learned in our application of derivative, in case you have forgotten it, I can recall about that. So, if I have two curves like this, which are intersecting at certain point, let us say this particular point P, okay, and this is my equation of curve C1, and this is my equation of curve C2, right? Now, if I draw a common tangent at point P, now if I draw the tangent to the curve C1 and C2 at this point P, and let me call this tangent to C2 as T2 and C1 as T1, right? Therefore, this particular angle which is made by the tangents at the point of intersection is therefore defined as, so this particular angle is therefore defined as angle between the curve. Okay, it is defined as the angle between the curve, right? Now, if I try to find out this particular angle can easily be found out by finding out the slope of the tangents, right? All right. So, where m1 and m2 so are the respective slopes of tangent t1 and t2. Okay, and we have already seen how to find the slope of the tangent, that is basically dy dx or derivative with respect to the first curve at point P, and m2 is basically given as derivative of the second curve at again point P. Okay, so if I do this particular form, then I'm going to get to the angle between the curves, right? So once I know the angle between the curve, then if this particular angle, this theta angle, if this theta angle becomes pi by 2, then tan of theta won't be defined. So this won't be defined only when I have m1 into m2 as minus of 1. Therefore, from here I can write, by substituting the derivative form of the slope, I can write this derivative of x y1 with respect to x multiplied with derivative of y2 with respect to x should be equals to minus of 1, right? Now, from here, this gives our best and important idea that if I have the family of curve as given in terms of y1, and in order to find the orthogonal trajectory of y1, we have to replace the derivative of y1 in terms of, so y2 by derivative of y2 upon x is equals to minus of 1 upon derivative of y1 with respect to x, and this I can replace as minus dx upon dy1. Okay, so if I have our derivative, or if I have our family of curve in form of y1 and x, then in order to get to the, so this is y2, okay, so in order to get to the orthogonal trajectory of y1, I have to just replace the derivative with respect to x to a small change, that is you have to write the derivative in term of minus dx by dy1. All right, so therefore if I do this particular transformation and then I solve for the differential equation, then I will be able to get to the differential equation, or the solution of the differential equation will therefore yield me the solution in terms of y2. That is the orthogonal trajectory of the following curve, that is of y1. I hope this is clear to all of you. I hope this discussion is clear. If you have any question, please let me know in the live chat. Any questions so that we can discuss over it? Any questions? Alright, so if you have no questions, then let's me discuss about this particular thing, right? That why for a circle, any straight line passing to the origin becomes the normal, or it is basically the orthogonal trajectory. So if I try to write this equation of the circle, so let me take a very simple equation of circle, that is x square plus y square is equal to a square. So if this is my simple equation of the circle, if this is my simple equation of the circle, okay, then let me first of all find a differential equation of this form, right? So over here I can see there is only one arbitrary constant. So if I differentiate with respect to x, so if I differentiate with respect to x, so I will get 2x plus 2y dy upon dx is equal to 0. So our differential equation from here, dy upon dx becomes equals to minus x upon y. So our differential equation becomes dy upon dx is equal to minus of dx minus of x by y, right? So if I solve this differential equation, I will get to the family of the circles, right? But if I want to find the orthogonal trajectory to it, if I want to find the orthogonal trajectory to this particular set of curves, okay, what I need to do is that I just need to replace this dy upon dx term with minus of dx upon dy, and that will be equals to minus of x upon y, right? And now I can easily solve this differential equation by doing simple variable separable form, that is dx upon x is equals to dy upon y, and then if I integrate both the side, I will get natural log of x is equals to natural log of y, and the constant I can write as natural log of c, right? So therefore from here what I can see is that I can write this natural log of x as some natural log of y into c. Therefore from here I can write x equals to y times of c, or I can also write this some constant as m times of x equals to y, m times of x equals to y, right? So this is basically the equation of the straight line passing through the origin, right? So therefore when I try to find out the solution for the orthogonal trajectory, I always find that it is basically becoming a straight line passing through the origin for a circle, right? So the orthogonal trajectory or a family of circle is basically all the family of the straight line passing through the origin. All right, passing to the origin over here. So all set of straight lines passing to the origin is a orthogonal trajectory for the given family of circles. I hope this is clear to all of you. I hope this solution is clear to all of you. All right, is this part clear? Please let me know in the live chat, is this clear or not? Is this part clear to all of you? If you still have any questions, please let me know so that we can discuss about the solution. Okay, so that I can also understand that whether you are able to get the solution or not. Okay. Please let me know if you have any questions, any problems. Okay, so I think you don't have any questions. So then we can discuss about some more problem, right? Alright, so similarly that you have found the orthogonal trajectory for the pair of or family of circles. Similarly, can you try to find out the orthogonal trajectory for the family of rectangular hyperbola? So if I have, so please try to solve this problem. So find the orthogonal trajectory for rectangular hyperbola, for a pair of rectangular hyperbola which is given as xy is equal to c, or xy is equal to some constant as c. Okay. All right. Please try to solve for this. Please try to find out the solution for this orthogonal trajectory of this pair of rectangular hyperbolas. Okay. So if I have the following rectangular hyperbolas as xy is equal to some constant c, then try to find out the orthogonal trajectory for this pair of rectangular hyperbolas. Okay. Please try to find out, and then we'll compare with the geometrical understanding of that as well. Right. It's a fairly simple problem, I know, but again, important, right? Because sometimes in JEE Mains, there are questions on orthogonal trajectory. Okay. Okay. So please try to solve this problem. Please try to solve this problem. Any answers? Any answers? So first of all, looking at the given problem, what you have to find is that, so you have been given the family of equation as xy is equal to c, right? So first and foremost thing is to construct the following differential equation, right? So from this particular form, the first and foremost thing is to construct the differential equation. So over here you can see that you have only one arbitrary constant. So if I differentiate with respect to x one time, then I'm going to get y plus x times of dy upon dx is equal to some 0. So our differential equation is going to be dy upon dx is equals to minus of y upon x, right? So our differential equation is going to be dy by dx is equal to minus of y upon x. Now, in order to find the orthogonal trajectory for this set of differential equation, so in order to find the orthogonal trajectory for this set of differential equation, what I need to do is that I need to replace this dy upon dx with minus of dx upon dy, and that is basically going to be equals to, and that will be equals to minus of y upon x. So if I do the variable separable over here, then minus of dx is equals to, sorry, plus of dx, x into dx is equals to y into dy. So if I just integrate both the side, then I'm going to get the solution as, so the solution of this orthogonal trajectory is going to be equals to something like this. So let me call this c dash, okay, another constant. Okay, so x square minus y square is equals to some c dash, which is another constant. Now, if you recall, this is another equation. This particular equation is basically an equation representing the hyperbola. This is basically an equation representing another hyperbola, right? So the differential equation for orthogonal trajectory for the given family of hyperbola is another hyperbola over here. Alright, that is x square minus y square is equal to c, which is the required orthogonal trajectory. Alright, is this clear? Is this part clear to all of you? Is this part clear? I hope the solution is clear to all of you. I hope the solution is clear. Alright, I hope this is clear to all of you. So, depending on this particular types of problems, we can also solve some more types of problems. So, I would like to give you some homeworks to find the orthogonal trajectory. So, please try to solve some more problems on find the orthogonal trajectories trajectory for the following curves. So, you have another curve where cx square is equal to y, one set of curve. Another curve is given as so you have to find another orthogonal trajectory for this set of family of circles like this, that is given as x square plus y square minus 2cx equals to 0. That is, the center of the circles is lying on the x axis. Okay, and sorry. All right, and also for a set of parabola. So this is third problem for set of parabola, which is given as y is equal to cx square plus some constant k. Y is equal to cx square plus some constant k. Okay, plus some constant k. So this is another problem. So for these three equation of curves, please try to find out the family of orthogonal trajectory. Okay, please try to find out the family of orthogonal trajectory. All right, so this will be your homework problem for your next class. Okay, so before we end or conclude this class, please try to solve these two problems or the three problems and let me know the solution in the comment section of this particular lecture. Okay, so once we are done with this particular lecture, then we are ready to now proceed with the discussion of exact differential equation. Okay, so our next understanding is going to be discussing about exact differential equation. Okay, so now we are ready to discuss about exact differential equation. Okay, so now we are ready to discuss about the exact differential equation, right? So this is something that I'm going to do in the next class. Okay, so we're going to discuss about the exact differential equation in our next session. Okay, so for till then, if you're new to this particular platform and you have found this particular gold mine today itself, then please subscribe to the channel and also hit the like button and also click on the bell icon so that you don't miss out any upcoming notification, that whenever we are live, you always get the direct notification on our channel. Okay, so and also share these videos with your friends, your family, relatives, as well as any of your juniors who are preparing, who are currently in class 11th and they are preparing also for the JEE Mains Advanced as well as any other competitive examination where the syllabus is basically similar to that of the JEE examination. Okay, so with this, and also if you are interested in taking one-to-one live online batches or you want to study in a personalized mode of environment, all right, you can always contact me on this particular number that is given in the description box. Okay, or if you have any doubts, you can always call or WhatsApp on this particular number 85092797763. Okay, you can call or WhatsApp on this particular number. You can call or WhatsApp on this particular number. Okay, and so for any queries, any discussion, you can always call or WhatsApp on this particular number. Okay, so with this, I would like to conclude the session over here and thank you for your attention, and I hope to see you in the upcoming lecture where we're going to discuss about the exact differential equation, and with that we are going to finish up the chapter of differential equation, and then after the lecture number 10 we're going to start with a new chapter, that is vectors and 3D geometry. I hope this is clear to all of you. So thanks a lot for your attention.